Hi guys, Mrs. Delisin here. Welcome to another lesson of Algebra 2. Today's lesson is how to simplify nth root. It might be a little bit complicated at first, but hopefully the strategy that we are going to be using is not that hard for you to understand. But first, let's deal with some things that are simple. When we say a square root of 25, what does that really mean? Right? The square root of 25 has an index of 2 because square root means, index means the number on this little corner here. When we just put square root of 2, we don't necessarily have to put the 2 because we know it's 2. We know that we're looking for a pair of number that will result into that number that is inside the radical. So what is a pair? What is in a pair of a number, right? When you multiply to each other, you'll get 25. And we know that, it's just a 5 because 5 times 5 is 25. Or we can rewrite this one as the square root of 5 squared. And because of this 2, the 2 gets canceled and our answer is just 5. Does that make sense? Okay, let's have another example. What if we have maybe 125? So we have a cube root this time, a cube root of 125. So really what that means is that what is that number that when you multiply to itself, cube root means 3 times. You multiply to itself 3 times, you will get 125. And that number is going to be 5 cubed. Because 5 times 5 times 5 will give you 125. And so this 3 cancels out that 3 and the answer is just 5. So every time the index matches with the exponent, the radical gets canceled and the number goes outside the radical. I'll repeat. Every time the index matches with the exponent, the radical gets canceled and the 5 goes out of the radical. And anything that is a remainder will stay inside the radical. Okay, maybe last example of that. Like let's say the fourth root. Like we're transitioning from 2, 3 to 4. The fourth root of, let's say 81. Okay, so technically, we are looking for a number that when we multiply to itself 4 times, the 4 means the fourth root. This one will tell you how many times you have to multiply the number to itself. If you multiply to itself 4 times, we'll get 81. And that number is 3. Because 3 times 3 times 3 times 3 is 81. And because this 4 goes into that 4 perfectly, this cancels out. Because again, whenever the index matches with the exponent, the number goes out in the radical. So the answer there is just a 3. So, our goal today is to match our index to our exponent. Because whenever that happens, you will just cancel the radical and the number will just be outside the radical. And anything that doesn't work out or doesn't match will stay inside the radical. So let's try, it's a very big number, 384. And we don't really know what that is because it's a very big number. You know how earlier 125 seems easy, 5 times 5 times 5, but the 384 seems to be a little bit challenging. So the easiest way to do that is you make a tree. So let's make a tree. We call that a factor tree. So of course you can just always do 384 divided by 2. But I don't really like to use small numbers because the tree gets super long. I'm going to be using 16 times 24. That's 384. That's a 4 and a 4. And 4 and 6. 2 and 2. 2 and 2. 2 and 2. That's too much 2. 2 and 3. And we need to remember all of these. So we are going to put that back into the radical. But instead of, you know how you're doing 384, I'm no longer writing 384. I'm going to be working on, I'm going to be putting all the numbers, all the prime numbers I got from the tree. So this is the 6th root of 2 to the, how many 2's are this? 1, 2, 3, 4, 5, 6, and 7. 2 to the power of 7 and 3 to the power of 1. And that would, you know how when the exponent, when the index, not exponent, when the index matches with the exponent, the radical gets canceled and the number goes out. Does that make sense? But in this case, the 6 goes to the 7 one time, right? But we have one remainder. We have one thing left. Does that make sense? Or I could, if you're confused, we can rewrite this way. Look, I could rewrite this into 2 to the power of 6 times 2 to the power of 1, and of course 3 to the power of 1. And this 6 and 1, of course, it will still be 7. But I just break them down into 2 pieces because I wanted to be able to cancel this 6. Does that make sense? Okay, so every time we have like a number that doesn't match with our index, we will just break it down. So here's what the idea is. And because this 6 and that 6 is the same, this 2 goes out. So this 2 is now up because it cancels out. So you have a 2 on the outside. And then because this 6 does not really go to the 1, this 2 is going to stay inside the radical. And because this 6 does not go into that 1, this 3 will stay in the radical. And so our final answer is going to be 2 times the 6th root of 6, because 3 times 2 is 6. So final answer here would be 2 and the 6th root of 6. Does that make sense? Okay, moving on. We have 224. Again, you can do 224 divided by 2, but I'm going to be using 16 times 14. 16 will be 4 times 4. 14 would be 7 times 2. That's 2 and 2. 2 and 2. And I don't think I can simplify the 7 anymore, so I'm going to be ended up with this. And let's put them back into a radical. That's the 5th root of 200. So 2 to the power of how many is this? 1, 2, 3, 4, 5. So 2 to the power of 5 times 7 to the power of 1. Wow, good. Because the 5 goes into that 5 perfectly one time. We have 1, 2 on the outside. And then the 5 does not really go to a 1. So the 7 will stay inside the radical. So our answer is going to be 2 times the 5th root of 7. Okay. Make sense? Moving on. Ooh, a negative. Remember now, this is not going to result into a square root of a, or into an imaginary unit, because it will only result to imaginary if this is an even number, but it's not. So it will just be a negative answer. Okay, what's 216? You can, again, 216 divided by 2, you can do that. I will use 6 and 36. That's 3 and 2. 6 and 6. A bunch of 3 and 2. 3 and 2. Okay, but of course, one of them must be a negative, right? Any of them can be a negative in order for us to get 216. And take note, we have an x to the power of 5 going on in here. So, I will rewrite 3. So we have how many 3's is this? We have 3 to the power of 3, 2 to the power of 3, and x. Okay, you know how x to the power of 5? Because you know I wanted to cancel the 3, right? So the 3 goes into the 5 2 times with a remainder of 2. But sometimes it could get what? What is that? We can break down the x to the power of 5 into, let's change the color. X to the power of 3 times x squared. Does that make sense? That's still a 5, right? That's still 5 x's. Yeah? Okay. And so, I will then, and every time, remember, every time the index matches with the exponent, that gets canceled and the number goes up. So, let us identify which one goes out and which one will stay in. The 3 index matches with the exponent, so 3 out. The 3 matches with that 3, so 2 out. Not 32, okay? 3 times 2. This 3 matches into that 3, x out. This 3, though, does not go into that 2. So the x squared will remain inside of the house. So our final answer would be 6x with x squared. So, but we forgot. Let me make that pink. Remember that it was a negative 216. One of these must be a negative. So this is a negative, and this is a negative. So our answer is negative 6x and a cube root of x squared. Okay, 405. 405, not bad, because it is divisible by 5. So we have 81, right, times 5. 9 times 9, 3 times 3, 3 times 3. So we ended up with, okay, we have the 4th root of 3 to the power of 4. Oh, wow. The 4 matches. 5 to the power of 1. And again, the x, do you see this x right here? To the power of 9. I'm going to break that down into x to the power of 4, x to the power of 5. Right? Because x to the power of 4 plus x to the power of 5, if I multiply these two, I'm going to end up with x to the power of 9. Okay. Every time it works, every time it has an exponent that is a 4, it goes up. Every time it doesn't have an exponent of 4, it stays in. Okay, here's the idea though. You know how I did x to the power of 4 and x to the power of 5? And if you notice, the 5, there's still a 4 in it. So what if I do it into x to the power of 4 and x to the power of 1? Okay? That's still 9, right? Or, there's so many ways you can do it. Or, because, no. Got deleted. Or, I could do x to the power of 8 and x to the power of 1. Because the 4 goes into the 8 also, right? 2 times. Okay, let's do this. I'm going to write, I usually write the 4 already. So, the 4 goes into the 4, so the 3 will go out of the house. The 4 does not go into the 1. 5 stays in. The 4 goes into the 8 twice. So you have 2 x's on the outside, so you have an x squared. The 4 does not go to 1, so the x stays in. So your answer is 3x squared with the 4th root of 5x. Okay. Moving on. Maybe 2 more examples and we're done. Okay. We have, 320. Not that bad. 320 is a really nice number. We have 32 times 10 We have 8 and 4, 5 and 2, 4 and 2, 2 and 2, 2 and 2. Did I simplify everything correctly? Wow, I have an X and then a Y. That's a lot. So we have the 6th root of, change, 6th root of, how many 2's do we have? 1, 2, 3, 4, 5, 6. Oh, it matched perfectly. Very good. 2 to the power of 6. And then I have 1, 5, 5 to the power of 1. And then I have x to the power of 6. I don't have to rewrite that, right? Because it matched perfectly with my 6. And then I have y to the power of 6. Oh, let me change the color of that so you can see the difference. So I have y to the power of 7, but I want to make sure that it matches with my exponent already, so it's easier for me to cancel them out. Okay, some answers go inside the radical, some answers goes outside. And if the index matches with the exponent, it gets canceled and the number goes out. So 6 and 6, the 6 goes to 6 one time. So there's a 2 on the outside. The 6 does not really go to 1. So 5 stays in. The 6 goes into the 6. So x is out. This 6 goes into that 6. So y is out. This 6 does not go into that 1, so y is in. So 2xy, the 6th root of 5y. Okay. I think we could stop with this example. Let's see if you guys are going to be feeling better with that. We have 256. We know that that answer will be a negative at some point. So I'm even going to put a negative so I don't forget. What's 256? You can divide that by 2, but I can use usually like big numbers already. 4 times 4, 4 times 4, 2 times 2, oops. 2 times 2, 2 times 2, 2 times 2. Oh, that's a lot of 2's. Okay. So let's put them back into the radical. I have, 5. So I'm going to have 2 to the power of how many? 1, 2, 3, 4, 5, 6, 7, 8. But I have a 5 here, but I can, what if I already can I break them down already? So 2 to the power of 5 and 2 to the power of 3. That's 8 together, isn't it? Okay. And then my x, let's break the x also. X to the power of 5, x to the power of 2. Why did I do that? Because I have 7 x's right there. But then I want one of them matches with the 5, so I'll break them into 5 and 2, which is 7. And then I don't have to break the y, fortunately, because the y matches with the 5. Okay, I mean the exponent of the y matches with our index. Okay, if the index matches with the exponent, it goes out. So 5 and 5, 2 out. 5 and 3, the 5 doesn't really go to 3, so the 2 cubed stays in. 5, does that go with 5? Yes, so x out. We have 5, that doesn't go to 2, so the x squared in. And then you have 5 goes into that 5, so the y will be out. All right, does that make sense? So this is 2x to the 2xy. And again, you can simplify once inside. 2 cubed means 2 times 2 times 2. That is an 8x squared. Okay, something that we forgot, which I did intentionally do it, so that way you can, take a look at our answer first. You know how this is a negative 256? If I multiply all of these, this, of course, will be equal to 256. But one of them must be a negative. So this must be a negative. That must be a negative. That must be a negative. So our final answer is a negative 2xy. the fifth root of 8x squared. Okay. I'm doing the last example, and then that's it. I think we can conclude this lesson right after. 405, that would be 81 times 5. And 9 and 9. 3 and 3, 3 and 3. So I ended up with the fourth root of, seems to be long, 1, 2, 3 to the power of 4. Wow, it matches already. We have 5 to the power of 1. X to the power of 5. So can I write it this way? X to the power of 4, x to the power of 1. The y you don't have to worry because it matches it perfectly. And then the z, though, we can do z4 and z3. Right? Altogether, it's 7. So every time it works, it goes out. Every time it doesn't work, it will stay in. The 4 goes into that 4 one time. So there's a 1, 3 on the outside. The 4 does not go to that 1. So the 5 will stay in. This 4 goes with that 4. So one time. So you have 1x on the outside. This 4 does not go to that 1. So this x is inside. This 4 goes to that 4 one time. So you have 1y. This 4 goes to that 4 one time. You have 1z. This 4 does not go to the 3. So you have a z cubed. So your final answer is 3xyz, the fourth root of 5x, z cubed. Okay, there you have it. And that's how you simplify nth root. If you guys have any question or you need clarification with any of the examples, please let me know. Thank you for your patience and for listening. I will see you guys in the next video. Thank you.